Hello, and welcome to Retro Tech Repair. Today we're doing another rough cut video. In these videos I spend a little bit less time in the post-processing in order to bring you content more quickly. Nonetheless, I think it's an exciting video today. I really hope you enjoy the content, and if you could take a second just to hit subscribe, that would be amazing. Thank you so much for watching Retro Tech Repair. Today we're going to be looking at the CGL Galaxy Invader, and I'm going to tell you a little bit of the story about how I came to own 3 of these. So we're going to start off with this. When I first started Retro Tech Repair, I wanted to have a go at repairing vintage items that I bought on eBay, and the first item that I bought to repair was this. I started down the repair path and shot some video of it, and I got some way through the process, and then I just stopped. I didn't know enough, I didn't have enough experience, didn't really know what I was doing, and I wasn't able to solve the problems that I was having with it. We'll take a look at some of the earlier footage a little bit later, but what I want to do now is come back to it with the things that I've learned recently, now that I've restored or repaired a few different games and handheld devices, and see if I could actually repair it where I wasn't able to repair it the first time. What I thought was, well, you know what, I'll buy another one, and I'll see if I can use that other one to help me diagnose the first one. So I bought this one. This was the second one that I bought. And when I opened this one up, what I found is that actually it's not the same as the first. On the face of it, it looks the same. The switch is a little bit different, but when you look at the printed circuit layout, things aren't in quite the same place. There's a capacitor here that isn't here on this board. There are some diodes here that aren't here on this board. And when you turn it over and take a look at the layout, this has a printed circuit assembly, I think it's labeled Gakken. And when I take a look at this one is altogether different. The quality of the soldering doesn't look nearly as nice, and it's covered in this kind of thick conformal coat that's kind of clumsily applied versus how neat this is. It looks like there's a lot of flux residue and some other things on there. This one doesn't look quite as good. So because the printed circuit layout was completely different, I thought, well, I can't use this second one to help me diagnose the first. This also was bought as faulty. So I thought, well, what's the difference? And when I looked, this one doesn't have the Gakken label on. And in fact, when I look at this one is made in, is it labeled on here? Or perhaps I need to look on the box. This one is made in Taiwan. The first one was made in Japan. This is made in Taiwan. So I thought, well, okay, well, I need another made in Japan Galaxy Invader to help me debug the first one. So that's when this one came in. I thought, well, I'll buy another. And here it is. So I bought this full of excitement. When it actually arrived, none of the screws were in. It's like somebody had already been in this one. These two I took apart myself, but this last one arrived in pretty much this state. Yeah, the VFD display was crooked. I've straightened it a little bit. But then I'm like, well, hang on a minute. This is similar to the first one, but it's not exactly the same. So even though this one over here was made in Japan, the VFD looks quite different. See, the vacuum port is in a different place to this one. Layout here of these 3 diodes and this resistor is slightly different. Again, we have 3 diodes here where we have, and 1 link where we have just 3 links here. There's no capacitor here again. So again, this is different, and it's different to the other one. This one has a slightly neater printed circuit assembly, and this one also has the Gakken and Japan written on it, although it's a different layout to this one. So I bought 3 Galaxy Invaders, the first one to repair, the next one to help me repair the first and also to repair, and then a third one to repair. And it ended up that I had 3 Galaxy Invaders and nothing really I could do with any of them. I got these in the wrong order. So what we're going to do now is we're going to take a quick look at the footage from the first one, and then we're going to come back and take a look at this one and see if we can get it to work, and then we're going to turn our attentions to the other 2. Hello, so here we are with our Galaxy Invader. As you can see, it's pretty well used. It has the battery compartment lid in place, which is nice, and the battery terminals have a little bit of corrosion on them, but really are not too bad at all. The screws, which are a feature on the front, they're really just molded into the plastic as a design feature. Those have been gnarled. The first thing we're going to do here is just slide some batteries in. They seem pretty tight apart from this last one, so we might just have a go at jiggling that around in a moment. But for now, let's just turn it over, switch it on, and we'll see what happens. And as the seller described, absolutely nothing happens. And we'll see what's going on inside of here when we strip this down. Top comes off pretty easily. We see we have some capacitors. We've got this little foam disc here, which I think probably belongs over here and is the piece that was missing off the joystick, so it's quite nice to find that. I think what I'm going to do next is I'm going to take this board out, we'll get the meter on it, and we'll see if the power from the battery compartment is in fact making its way to the main board there. Okay, so I'm back, and as you can see, in fact when I went to disassemble this, I ended up breaking this ground cable here to this connector here. So what I'm going to do is I'm going to put a longer cable in now, a longer piece of wire between the earthing point and the battery connector. Hopefully that will give us a little bit more room to work as we try and diagnose what's going on here. Hopefully now we will have power to the main board and just a little bit more flexibility on how we can position this and still work it. So let's turn it over and put those batteries back in. We have batteries in there, and as you can see it is still dead. So we'll go ahead and get the meter and we'll start finding out where we have power, where we have connectivity, and what is going on. And when I put my voltmeter across the contacts here, I see 4.8, 4.79 volts, a little bit less than I would have expected, perhaps 1.5 volt cells. I'd have probably expected to see 6 volts, right? And in fact, instead of seeing the 6 volts, I'm seeing only 4.8. I'm not quite sure why that is. When I switch it on though, that 4.8 quickly falls away to less than 1 volt. So it looks to me like something is dragging that supply down from the voltage it should be. Yeah, I'm not quite sure what would be causing that. Maybe it's one of the electrolytic capacitors on the board that has failed. They are quite old. I'm not an expert in this, but I know that these are not supposed to pass DC current, but sometimes do, so maybe if there's one of those that has failed. So what I think might be happening is that these electrolytic capacitors here, one of these might have gone, and that might be acted more like a resistor, and instead of blocking DC, just pulling that DC down to ground. So what I think I'm going to do is I'm going to start lifting legs on those capacitors and see if I can get us back up to 5 volts on the 5 volt line. I think I'm going to start with this one here for no other reason, well, for no reason at all really. Alright, so I think we've probably freed that one up. We can get its leg out and out of circuit. Okay, 5 volts. Metal 6, just over 5 volts. Measure across here. Again, 5.9 volts. We lifted the leg on that capacitor, so we know that's not the problem. We'll turn it on and we'll see if we still have 5 volts here. Well, no. Okay, so we did unsolder that cap correctly. Well, not about correctly, but certainly we did unsolder it. So again, the routine you're quite familiar with now, I'm sure. We are going to just take some voltage measurements. So I can measure the voltage again on our DC input, 6 volts. That's interesting because we had said from the start, I think, that we would have expected to see 6 volts there with us having 4 1.5 volt cells, and in fact now we do see that 6 volts. And I see from the front here we have some flashing. Excellent. It looks like we've sprung into life. So clearly that capacitor there was our problem, or at least some part of our problem. So what I'm going to do now is I'm going to replace this and I'm going to solder this one back in, and we'll see if we can get this finally working. Alright, so I have my replacement capacitor here. I'm just going to slide it into the board. They are polarity sensitive, so I'm making sure that I have it in the same orientation that that the old one was in. I'll pop the ends off of those. We'll turn it over and we will see what's going on up front. Well, nothing at the moment because it's turned off. Hopefully when we turn it on, we'll get something different. Well, that's a little disappointing, isn't it? So I think what I'm going to try and do now is I'm going to take a look at these other two electrolytics, see if we lift those from the board, whether we are going to have the same problem or not. Alright, here goes. Still nothing. Maybe we'll just go ahead and replace these anyway, since we have them half out. Oh, it is 2.2 microfarads. It was a different brand to the other capacitors in there. So now, of course, if it were a replacement, we can't guarantee that it's the correct value, but we will just solder that in now. We'll pop a battery in it and we'll see what it does. I'm finally about out of ideas, so we'll try it one more time and we'll see what happens. Nothing. Again, nothing. So hopefully by now you've seen the earlier video. And what I'm going to do next is I'm going to go ahead and connect a power supply up to this. So we have this set to 6 volts and I just need to connect it up. I think this is the negative. So obviously there's a wire that I just kind of soldered in badly the first time around, and then if I go onto the positive here, like so, and then we're going to switch on. Nothing. Switch on again. Nothing. So this is about as far as I got the first time. And then what happened was I switched it on. As I'm sitting thinking, and thinking some more, and thinking some more, this happened. Yeah, I don't know if you can see that. I'll drop one of the lights in order that you can see it a bit better. And what you can see now, hopefully, is that the display came up. So we're going to do that again. Switch it off. Switch it on. Looks like nothing's happening. 1, 2, 3. There we go. And then it comes up. You know, it feels like there's some kind of timing circuit that's involved. So from the point where I switch it, maybe there's some kind of timer that runs, then resets the CPU, and then it goes. And timers are often RC, resistance and capacitance timer. So I looked then at this recap that I had done. And when I look at the recap that I had done, and in particular this one, which caused me the most trouble actually, and it's one where when I did it first time, I broke the track and I had to run a jumper across and everything else. And when I look at that, it's a 47 microfarad cap is what I put in that place. Now, I go back to my other Galaxy Invaders, the ones that I'd previously shown you. When I look on there, I see that that capacitor is actually 0.47 microfarads. So that's a 0.47 microfarad. I put a 47 microfarad in there. So it's 100 times larger than it should be. And then I went back to this. This is the other one that I had. I looked at the same part on that, and again, that is 0.47. So I put a value in there that's 100 times larger than it needs to be. I think that might be our problem. So I'm going to go ahead now and change that out. And instead of the 47, I need a 0.47, which I do have here. Now I think, as I mentioned in the first video, they are rated by voltage also. That's 0.47. They are rated by voltage also. Now the voltage isn't too important. We need to make sure that we're not applying a voltage that is higher than the rated voltage. And in fact, we might even want to make sure we have some derating in there, as they call it, where you have a little bit of headroom, if you like, between the voltage that you pick and the voltage that the device might see in use. But the important thing is here that the capacitance is right and the voltage is at least as high as the outgoing part, and we lost the outgoing part. This is a 25 volt one that's in there now, and this also is 25 volt, I believe. But anyway, this is the 0.47. They are polarity sensitive, so we need to get this in where the other one was. Okay, in this pin, and here also. A little hot. There we go. So we'll put this back in. The negative is the shorter lead, and the one that goes to this track over here. I feel like this soldering iron might not be quite hot enough. There you go, and that little increase in temperature on the iron there has made a nice difference. I'll come back and trim that when I'm comfortable that this has solved our problem. So let's connect it up and see. Still have 6 volts on my supply. Negative to the negative supply. Positive to the power adapter. Turn it off. Let's turn it on. Straight away. Again, don't know if you can see that with the light. See if we can adjust that. That's a bit clearer. Yeah, maybe I should leave it like that. A little bit less shadow, a little bit more mood. I don't know. Let's see. That might be better. Maybe I'll shoot some more video with that lighting arrangement. Seems I want to focus better as well. So let's switch that on. And again, that comes up straight away now. And we're able to play the game. This is a monochrome game. On some of the others, Astro Wars and Scramble, you'll see are colour, they will put a colour kind of film, like a cellophane, coloured cellophane, in front of the display to give the illusion as different colours as it moves down. They don't do that with this. It's just a monochrome game. It is what it is. And we can try it again now without the lighting, just in case that last one didn't come out too well. Okay, very good. So this is really repaired now. It needs to be reassembled into its enclosure, but I'm going to see if the others work okay, because I actually have some different and maybe nicer enclosures that I could use if, in fact, we can't get the other ones going. So that's our first one. That's the first one that I bought that I wasn't able to repair the first time around.